In this video, we're going to take a look at how to multiply and divide by 1,000, 100, 10, and 1. And then at the end of the video, we'll take a quick look and see if we can multiply by some other related numbers, 0.1, 0.01, and 0.001. Okay, so to do this, we're going to need to think about our place value columns. So let's quickly draw that out. So if you remember, we're going to have, let's start with the units here, and tens and hundreds and thousands. And we usually have a decimal point, and then we have tenths, okay, and then we have hundredths, and then we have thousandths, right? So we can write some numbers into this grid very, very easily. So for example, A, we're going to have 362. Now, there's no other values in there, right? Okay, but I know it's not convention to do this, but we could very easily just carry this on, right? Okay, and we could place zeros everywhere because there's nothing in there, is there, right? Forever in both directions, we've got zeros. So that's really what that is. Now, if we're going to multiply it by 100, it's going to get 100 times as big. And your place value system is built in powers of 10, like tens and 100. So all we're going to have to do with this is to push that number, okay? So the hundredths are going to become 10,000s, right? Let's write that column in, 10,000s, right? Your tens are going to become thousands because they're all being multiplied by 100. So we're going to move this 2 spaces up, right? So this will become 3, 6, 2. Now, we still need to put those zeros in. We've got nothing else, right? Imagine all these zeros moving up, right? So our answer for A will be 36200. So what's really happened there? Well, you could say that, well, we can take that 100 and we see those zeros and we can just add those 2 zeros there. Well, that's true, but that isn't always going to be the case, as we're going to see from the next example. Right, so let's look at B now. So if we extend our columns on a little bit, and we're going to write in 4.73 into this. Let's see what happens when we multiply by 10. So 4.73 is going to be like this, 4.73. Now, if we are multiplying by 10, everything's going to get 10 times as big. So those units are going to become tens. Those tenths are going to become units. Those hundredths are going to become tenths. So everything is going to move up. We're going to only move up one place, though. So 4 goes there, the 7 goes there, and the 3 goes there. So our answer is going to be 47.3. So now we've got a better idea of what is happening here, right? If we are multiplying by 100, then we're going to push our values up 2 positions. If we're multiplying by 10, we're going to be pushing up by just 1 position. If we're going to multiply by 1,000, we haven't done that yet. Of course, we're going to push up by 3 positions. So what do we think is going to happen when we move and we divide? Well, it's going to be the opposite thing, isn't it? Because we're making things 10 times as small, right? Or in part D, when we've got that 1,000 there, 1,000 times as small. So we're going to be pushing things in the opposite direction. I mean, division is the opposite of multiplication. So let's see what happens. We will put in our 576. And we've got to divide it by 10. So things are moving backwards. The 5 will go now in the tens column, the 7 in the units column, the 6 in the thousandths column. So our answer is 57.6. 57.6. What about if we started off with 4.2? Right, we've got to move 4.2 and we're moving it further down. It's already quite a small number. So we're going to have 4.2. And because it's 1,000, we can see that we're going to be moving it 3 positions. So we better move our columns and make a few more, right? Our 4 is going to move 1, 2, 3 positions, and it's now going to be in that thousandths column. we better have the 10,000ths column. Right, the 2 is going to move to here as well. So that's where the positions are. And remember in the previous example, we imagine there being zeros everywhere, right? Just empty places. We don't write them, but they're there. Well, it's still going to be the case, but we do need to write them because we need to emphasize the position of that 4 and that 2. And if we don't write those zeros, no one's going to know that we're in the thousandths column or the 10,000ths column. So our answer here is 0.0042. Okay, so those are the answers to the questions. Now, let's just draw this out a second, okay, and sort of summarize our learning. So if we are multiplying, right, if we multiply by 1,000, okay, then we're going to move 3 positions to the left, aren't we? Right? That's what's going to happen. That's what we saw. And if we are going to be multiplying by 100, then it's 2 positions left. We're pushing those values all 2 positions left. If we're going to be multiplying by 10, then it's 1 position to the left. Now, let's continue that pattern on, right? Let's continue it on. Well, we've done 1,000, 110. So for some extension material, let's just consider what would happen if we made that just a 1. And what about if we even carried on and considered multiplying by 0.1 or even 0.01 or 0.001? What's going to happen then? Well, if I'm multiplying by 1, I'm keeping it exactly the same. The number I'm multiplying isn't going to change at all. So it's not going to move. It's going to be 0 positions to the left, right? And what about then 0.1? What's going to happen there? Well, if I'm going to multiply by a decimal number like this, I'm going to make it smaller. What's going to happen is it's actually going to be 10 times as small. It's going to move to the right. So actually, it's going to get smaller. It's going to be a bit like dividing. It's going to move 1 position to the right. And this pattern continues on, right? If I have a multiplication by 0.01, it will be 2 positions to the right. And multiplying by 0.001 will be 3 positions to the right. Okay, so let's make up a quick example, right? So what about if I had something like this, 82.3 multiplied by 0.01? Right, okay, well, we can do that. Let's think about our place value columns again, and let's write that in. So we are going to have our units and our tens. Let's put in our decimal point there, our tenths, our hundredths, and our thousandths. So this is going to be 82.3. So we're multiplying by a power of 10, 0.01. And if you remember, okay, 0.01, it means 2 positions to the right. So let's move them all 2 positions to the right. So the 8's going to go there, the 2 will be there, and the 3 is going to be there. Now that decimal place stays exactly the same. Let's fill the extra space with a 0 to emphasize where we are. And we've got our answer, haven't we? It is 0.823. Now, exactly the same pattern, but opposite is true of division, right? If we start doing division, now usually we know that if we divide by 100, then we're going to be moving 1,000. We're going to be moving 3 positions to the right. We saw that in the previous examples. If I divide by 100, it's going to be moving 2 positions right. If I divide by 10, it's going to be a movement of 1 position to the right. And we can again extend this on and think about, well, if I divide by 1, I'm keeping a number exactly the same. So therefore, I don't move at all. 0 positions to the right. And obviously, you can see this pattern happening, right? Okay, if I'm dividing by 0.1, then it's going to make a movement of 1 position left. 0.01 is 2 positions left. A division of 0.001 is 3 positions to the left. So there are some interesting patterns going on here, and there are some real equivalences. I mean, for example, if I'm going to multiply something by 1,000, that is identical to dividing something by 0.001. Or, for example, if I wanted to multiply by 0.01 and move 2 positions to the right, this is identical to dividing by 100. So there is a real pattern here. Now, these values, okay, for example, 0.01 and 100, they have a special relationship. They're doing equivalent things to each other when one is multiplied and the other divided. They are known as the reciprocal of one another. And if you were to multiply them together, you would always get 1. So these values are reciprocal of one another. 1,000 is the reciprocal of 0.0012. And there is a real equivalence here when we start to work with them. Okay.